Hi, kiddos. So this is for geometry semester two, final exam review or study guide. Number one, what is the definition for three trigonometric ratios? Sorry, that's supposed to be ratios right there, not rations. All right. So let's see. Sine of theta. So theta just represents whatever angle you're looking for, right? So it could be sine of A, B, C, whatever they call the angle. All right. Sine, if you guys remember, is really just going to be the opposite side. All right, divided by the hypotenuse. All right, so that'll be the ratio for sine. Now for cosine, cosine also divides by the hypotenuse, but instead of the opposite, it uses the adjacent. So the adjacent side divided by the hypotenuse. Tangent, he's the special guy. He only uses the legs, so he only uses the opposite side divided by the adjacent side. All right, so let's go ahead and see these trigonometric ratios in action. So number two, find three trigonometric ratios for angle C. So our reference angle is for C, so let's start with sine of C. Okay, so remember sine is the opposite over the hypotenuse, right? So let's go ahead and figure out who our opposite is of C. So we look across, and our opposite side is 24. And our hypotenuse is always going to be the longest side of the right triangle, which is always going to be on the opposite side of the 90-degree or right angle of a perfect or a 90-degree, or I'm sorry, a right triangle, which is 25. So the hypotenuse is 25. So that would be our trigonometric ratio for sine. Now let's go ahead and deal with cosine of angle C. Cosine, again, is going to be adjacent all over the hypotenuse. Our adjacent is literally the next door neighbor, who happens to not be the hypotenuse side. And then the hypotenuse, again, is still going to be 25. Sorry, that's ugly, 25, I know. All right, so tangent. Tangent is our third trigonometric ratio. Personally, one of my most favorite ones. Tangent. So again, tangent is opposite over the adjacent. Tangents, he doesn't really care about the hypotenuse. The opposite of angle C is still going to be 24, and the adjacent is 7. So there you go. Those are the three trigonometric ratios for angle C. You guys get to work with angle T as your reference angle. So number 3, totally for you guys to get your practice in. All right, number 4, if sine of E, all right, so this is our reference angle, equals 4 over the square root of 41. Okay, so let's use that information first to establish what's going on with our triangle here. Sine, right? Sine of E. Sine, again, sine of theta, in this case it's E, is going to be the opposite over the hypotenuse, right? That means 4 is going to be our opposite side. So who's on the opposite of angle E? DF, which is 4, okay? Now, who's the hypotenuse? Opposite of the 90-degree. That will be EF, which is given to us as square root of 41. So notice how this piece right here gave us that information. And we had to know this idea. So make sure you know your trigonometric ratios. That way you can apply them correctly. All right. Next piece of information, sine of E, right? And if you remember sine, or I'm not sorry, not sine of E, cosine, cosine of E. Well, remember cosine theta is going to be the adjacent over the hypotenuse. So that means your adjacent is that 5. So the guy next door, DE, is just going to be 5. So the tangent of E, all right, so we're still working with E, right? Tangent, if you guys remember, tangent is the opposite over the adjacent. Our opposite of E is still going to be DF, which is 4. And our adjacent is going to be DE, which is 5. So there is tangent of E. All right. Number 5, write the equation so it can be used to solve the missing side. Well, first things first is my reference angle. Okay, so that's the first thing you have to consider is one, what's my reference angle? Um, and it's obviously 40. Now, what is that side in reference to our reference angle? What is x? X would be considered our adjacent, right? He's our next door neighbor, but he's not the hypotenuse. And our hypotenuse is across from the 90-degree right angle, and that is our opposite. Well, we got the opposite and the adjacent given to us for our reference angle, right? Now, who uses the opposite divided by the adjacent, right? Who works with both of them? Oh, that's tangent. So we're going to have tangent of our reference angle, which happens to be 40 degrees, equaling to our opposite, which again is 19, right? Over our adjacent, which is x. Now we have to solve for the missing side length. So when we ever see solve for the missing side length, we have to isolate x. But look how x is being divided there. So let's go ahead and move him over by multiplying. But remember what you do to one side, do the both. And you're going to have x times the tangent of 40 degrees equaling 19. But we have to get rid of that multiplying tangent of 40. What's the opposite of multiply by tangent of 40? Divide by tangent of 40. All right, so just remember what you do to one side, right? Just like in algebra. There you go. And we could go ahead and plug this into a calculator. And just make sure your calculator is in degrees. So 19 divided by a tangent of 40 degrees. And I get this approximation of 22.64. There's no units, so that would be the end of it. All right, you guys definitely get B. Again, remember what's my reference angle? La di da da da, just like A, just you might deal with a different trigonometric ratio. So remember, you have sine, you have cosine, or tangent. All right, so think of those three right there. All right, number 6, flagpole. Cast 20 feet, shadow to the ground. Let's draw a pretty picture so we can get an idea. Got this flag. Okay, it's Memorial Day. All right, got this flag, America. All right, very nice. It casts a 20-foot shadow. So uh, there's a little shadow there, and that's 20 feet. All right, good. With the ground and the flagpole, we're going to assume is standing straight up, right? Like a normal flagpole, 90 degree from the ground, completely perpendicular. Now, let's see, if there is an angle with an elevation of 32 degrees, all right, so what it's saying is from the end of the shadow here, if you look up at the flag at the very tip top, your angle of elevation is 32 degrees. So, like if you were standing there, your head would be tilted up at that angle with the top of the flagpole. Yeah. So, let's see. What is the height of the flagpole? So, what is the height? All right. Um, well, okay. Isn't that a reference angle? Right. So, isn't that a reference angle? Now, who is h? See, the opposite or the hypotenuse or the adjacent? Who is h? And if you said opposite, you're on the right path. Now, who is the 20 feet in reference to your angle? All right, if you said adjacent, good for you. So if we're dealing with the opposite and the adjacent, well, the only trigonometric ratio that we know that has opposite over adjacent, and if you already know it's tangent, good, you're on the right path. So tangent of what? Well, they gave us a reference angle of 32 degrees, right? And again, that equals the opposite, which was h, which we're solving for, right? Divided by our adjacent, which is the 20 feet. Now, we have to isolate our variable, which is h, for the height. Let's go ahead and get rid of that dividing 20 feet. Now, that's the inverse of dividing by 20 feet, multiply by 20 feet. But remember, what you do to one side, you have to do to the other. So you're going to have h, okay, and I'll go ahead and write this all out for you guys. That's 20 feet times the tangent of 32 degrees equals h. You can use the whole symmetric property. So h equals 20 times tangent of 32 degrees. Don't forget, kiddos, that we're still working with feet here. So technically that's 20 feet. So just be aware of that. I got kind of lazy right there. All right. So in your calculators, real quick, you can do this. I think for your little tiny calculators, it's 32 tangent and then times 20. If you have a scientific calculator, um, check with your teacher, make sure you can use it on your test. But if you have a scientific calculator like a TI-83 or up, 20 times tangent, just type in the 32 and close parentheses. And you should get this approximation, okay, of 12.497. And we'll go ahead and keep it there at feet. All right. And if you want, you could round if it said to round, or if it was on multiple choice and they gave you 12.5 feet, that'd probably be the answer. If they gave you something even more accurate or precise, that would probably be the answer, but that would probably be around the ballpark figure of their multiple choice options. All right, so check this out. I'm only going to draw the picture for this, but number 7 is definitely for you. All right, so they already give you this palm tree. All right. Sorry, that's my palm tree. All right. All right, man. Yeah, that's my palm tree. All right. They say it's 50 feet tall. All right. And it casts a shadow of 30 feet. Yeah, I'm trying here, okay? Give me a break. Oh, that was the worst 3 ever. Threes is the most common number that I have issues with writing on this touchpad. So 30 feet for our shadow. What is the angle of elevation? So you are actually solving. Oops. Let me get this drawing a little prettier here. You are actually going to solve for your reference angle. So we do not know what our angle is there. Now, what is the 50 degrees? What is the 30 degrees in reference to our angle? And you should realize, well, that's opposite. This is the adjacent. And you basically have, well, tangent, right? If you're using opposite and adjacent, no hypotenuse, you're definitely working with tangent. All right, so tangent of what? We don't know. Tangent of x, we don't know. But that should equal our opposite over our adjacent, which is given to us as 50 over 30 feet, right? So you guys go ahead and figure out how to solve for x, and then come show me once you think you got the answer. But remember, if you're solving for that, you need to use the inverse of whatever trigonometric ratio you're using. In this case, we're using tangent, so use inverse of tangent. If you're got a calculator, you can get your answer real quick. But basically, it's just 50 divided by 30, second tangent, and you should get your answer. All right, matching. I want to do only the first matching. All right, so which ones that are equivalent? So what they're trying to say here is they're complementary angles. So they should say that sine of A should equal the cosine of B. Basically, it's like if angle A plus angle B had to equal 90. Okay, so that's really talking about complementary angles, which are angles that add up to 90 degrees. All right, so be aware of that word. All right, so sine of 60. If you guys actually do this, you could do a sine of 60 in your calculator, and you get like an approximation of 0.866 something something something. All right, but if you actually do a cosine of 30, you're going to realize, hey, I get the same answer. All right, and it's still the same exact decimal. It keeps going, but you're going to tell they're the same, and that's because A is B. All right, those two angles are complementary. So A matches with B, and you guys go ahead and figure out what else matches with what. All right, so again, the rest on number 8 is for you guys to practice with. All right, number 9, solve for the missing segment values. We got some missing segments. All right, cool, cool, cool. So let's go ahead and see here. We got 2 chords, right? So if we have 2 chords, we're probably using chord, right? Product theorem. So never forget about the theorems. And basically that says, well, this guy right here, x, let me use a highlighter, x times 6, so let me write that, or 6 times x, should equal the 9 times that 8, or that 8 times that 9. Multiplication is associative. So we got 6x, right? 6 times x is 6x. 8 times 9, 72. How do you get rid of a multiplying 6? Divide. Just remember what you do to one side, do the other. And you should get x equaling 12. So the missing segment was known as GI. So GI is 12. All right, so there we go. We just had to plug it back in. Be aware if it's 2x, right? If it's 2x, then you'd have to substitute in 2 times 12. And that would be 24 if that was the case. So be aware of that. B, same theorem, same process. And I think you got that figured out. So that's for you. All right, number 10, write an equation that would solve for the area of the sector. So we're dealing with sector area. Sweet. So it's like this. We all know the area formula for circles pi r squared. But now you really only care about a certain sector. So you don't care for the full circle. You just care for whatever the measure is of that little sector that you care about out of that full circle, which a full circle is 360 degrees, times pi r squared. So notice how there's a slight variation of the formula of the area formula back in 8th grade. So first things first, what's my measure for part A? Oh, 120. What's my radius? 15 millimeters. So to find our sector area, we really just have 120 degrees out of our entire circle times our pi r squared. R is 15 millimeters, right? But don't forget we square it like the formula says. And you can actually reduce, those zeros cancel out, and you can reduce even more by, let's try 3. Actually, no, we can try 12. And how many 12s are in 12? 1. How many 12s are in 36? 3. And then 15 times 15 should get you 225. Be aware, though, that you did the millimeters squared, so it's going to be millimeters squared. All right, so go ahead real quick. You can leave it like that if you want. Maybe multiple choice, you might see your answer like this. Normally, we would use a calculator. So if you did 225 divided by 3, you're going to get 75. If they left their answers, and they do this, they really do, in all kinds of different tests, CASP, SATs, be aware that sometimes they'll leave their answer in terms of pi. So that answer would work. If they left everything in decimal, all right, which sometimes they do, you have to be able to distinguish from both of them. 75 times pi is going to leave you with an approximation of 235.619. I'll round up. But be aware that all three of these possible answers could exist on a test, either of this final or even during a CASP test. Just be aware of the duality of answers. All right, so CASP, SATs, they might do something like that just to kind of like throw you off. All right, B. B. All right, B is for homework. I'm kidding, but yeah, B is definitely one that you should try. They already tell you your measure. They already tell you your radius. You got that. All right, number 11. All right, so indicated arc. Okay, so let's see here. What do we know real quick? What kind of angle is ADB? Angle ADB, right, is a inscribed arc, or I'm sorry, inscribed angle. That means it should equal half of whatever your measure for your arc is for AB, right? So if AB is 30 degrees, ADB will be half that, so that'll be 15. So that's kind of the theorem there for inscribed angle theorem. So that is inscribed angle theorem. So be aware that that might play out. It's always good to know the theorems off the top of your head. I mean, you never know when you're going to apply something that you've learned. You can't really predict the future, so you might as well know as much as you can. All right. Oh, look, dA equals 140 degrees. So this huge chunk is 140 degrees. All right, let me highlight that for you. So dA is 140 degrees. Then they tell us dB is 140. Also 140. Okay. Well, how much is in a full circle, right? And you're probably like, well, there's 360 degrees. Well, you have 360 minus the 140 from dA minus the 140 from dB, right? And you should realize that in the end, you just have a remainder of 80 degrees. Well, guess what? That's your remainder, isn't it? BA or AB. Well, if AB is that, and they're already asking, well, what's ADB, right? What's this guy? Well, if AB is 80, let's use the inscribed angle theorem. So what is half of 80 degrees? And that'll give you your angle for ADB, which is 40 degrees. All right. Part B, they already tell you that DEA equals CEB. Okay. Which equals BEA. Uh, Interesting. I think there's a slight typo. I think this is supposed to be DEC. Yeah. So this guy equals this guy, which equals this guy. And DEA is really, right, 180 degrees. Well, if they're split up in three different ways, that means this guy's got to be 60. CEB has to be 60. And BEA is also 60 degrees. Well, if their central angles are 60 degrees, that means their arcs are also 60 degrees, right? Their corresponding arcs. What is the measure for DA? Well, if DEA is 180 degrees, right? What's the other half of a circle? 180 degrees, right? Because like they already give you, all these guys, right? And all these guys equal 60, but there's three of them, right? So there's 360s already given to you for that half of the thing. And if all three add up to 180, then DEA is 180. So that's another way of looking at it. All right, number 12. So solve for the measure of the missing angles of the quadrilateral. What we should know is that right away, these are inscribed quadrilaterals and opposite angles are supplementary. That means that angle A plus angle C have to add up to 180. So if we're solving for this missing piece, well, angle A is already 74 degrees. Angle C we don't know yet, but we know that plus the 74 degrees, it should equal 180. How to let's isolate the variable for angle C. Let's get rid of that positive 74 with a negative, right, or subtract. What you do to one side, do the other. And you should get angle C equaling 100 and I'm trying to remember 106. There we go. All right, because 180 minus 74. So there's angle C. Also remember that all these angles have to add up to 360. So you could add up, or you could just take 360, subtract the 74, the 85, and the 106. It'd still get your answer for B. But instead, I want to use the logic here of opposite angles have to be supplementary. So angle D plus angle B really have to give you 180 degrees by definition, right? Angle D is 85 degrees. Angle B we don't know yet, but notice how the setup is very similar to what I did recently for angle C. All right, so subtract the 85 degrees there, and angle B equals 95 degrees. All right, yeah, so B looks very similar. So get your practice in, see if that you can do it. I believe in you. I believe you can solve for the angle in the quadrilateral. I see it every now and then. Man, it's been a while since I've. What was that, Space Jam? Wow. Okay. Number 13. Solve for the indicated side length. So let's see. TE. All right. So TE. TE is 7. ME is 25. So ME is going all the way across from this point to that point. What is the length of MT? Okay. So we'll make that X. Um, Interesting. All right. So one thing for sure that you have to be aware about when we're dealing with this is D. Is D considered the center of your uh, circle, right? So if you guys remember, if ME is your diameter, all right, and it runs through the center of the circle, by definition, there's an actual theorem for this. I think it's an inscribed right triangle theorem. But basically, it just says, well, if it goes through that way, then one of your angles has to be a right angle, 90-degree angle. It's a right triangle. So how do we solve for a missing side length of a right triangle? And that's probably where you should immediately remember this theorem. Sorry, that's an O. Pythagorean theorem. All right, he wasn't just a mathematician or a philosopher, he was also a cult leader. Yeah, crazy. All right, so let's figure this out. We have a squared plus b squared equals c squared. I'm going to go ahead and let my smallest side of my triangle be A. My hypotenuse is C. All right, and then B will be the missing side length that we don't know. So A is 7 squared. B is x squared. We don't know who he is. C is 25, and that's squared. And basically, we should get 49 plus x squared equaling 625, right? How do you get rid of the plus or positive 49? Subtract, right? Good old algebra. Algebra 1, I think even math 8 back in middle school, right? And then 625 minus a 49, you should get 576. And then how do you get rid of a square? Square root, but what you do on one side, do the other. And you should get plus or minus 24. But since we're talking about geometry and we can't have a negative distance, 24 is the only value for MT. So MT is 24. All right, so another thing is be aware sometimes CASP or SATs, they'll say X equals 24 for one of their answers, and then they'll say MT equals 24 for one of their answers. In context, MT would be the correct answer. All right. Whoa, same thing here. Same thing. So go ahead and get your practice in there, kiddos. All right, number 14. Write the equation of a circle with the center at, okay. So at this center with a radius of 6. So remember, we're working with this basic idea that we have x minus whatever x value they give us squared plus your y minus whatever k value they give squared equals your radius squared. Now, h, right, is -3 and k is -4. Your radius is 6. So if we substitute that in for our formula, x minus h happens to be a -3, right? And then we square it, plus your y minus your k, which happens to be a -4. Notice how I'm putting emphasis on the fact that we're substituting these integers into our formula, aka when I say integers, I say, negatives. Negative of a negative, positive, right? And again, negative of a negative, positive. And then don't forget your r is 6. So I should have probably wrote in 6 there. And then 6 squared, let me clean it up a little bit. There we go. There we go. Okay. 6 squared is 36. And boom goes the dynamite. That is our formula for our circle. Number 15 is a good one, definitely for you. Just remember when you square a radical, for example, if I was to square square root of 6, it would just give me 6. So don't freak out because they give you a radical for a radius. Don't freak out. All right, so number 16. Write an equation for the circle of the diagram. First things first, find your center. Okay, your center here looks to be at -4, comma 4. Our radius looks like it's 1, 2, 2 units here. Don't forget that's h and k right there. So let's go ahead and set up our formula. X minus my h value, which is -4, and we square it, right? Plus our y minus our k value, which is +4, square it, equals our radius, which is 2. Don't forget we squared that, right? So negative of a -4, right, is +4. And negative of a +4 is a -4. Don't forget we're still squaring it because the formula. And then 2 squared is really just 4. So there's our formula for part A. Part B is totally for you down here. Okay, for part B. Yeah, you got that. All right, number 17. Which figures are similar? Good. So we need to know our similarity theorems. I see two angles, angle A is co- congruent to angle x, and angle B is congruent to angle y. Now, remember when we talk about similarity, it's not that the angles have to be congruent, the side lengths have to be proportional. But right now, we're only worried about the angles. So this is actually just two angles, right? Well, triangle A, B, C, it's going to be similar to triangle XYZ, um, since we have angle similarity theorem. All right, so angle, just in case you're watching, you have no idea where AA comes from. There we go. All right. So remember, there's angle. There's also right. There's angle, side. Right. Um, side. Uh, but also proportionality. So let's look into this. So let's look at B. All right. We have GJ or JG. Good job, right? And he should be similar to the smaller side right here, right? So uh, JG should be proportional to LN, right? As should be the second smallest side length, all right? So GH or HG should be similar to or proportional to ML, as is the third longest side lengths, which is HJ or JH to MN. So JG was 4, LN was 6, GH was 8, ML was 12, HJ was 10, MN was 15. We can reduce all our fractions. I'll reduce the 4 6 into, let's see, factors of 2, so 2/3. Factors of 4 for the 8 and 12, right? So how many 4s are there in 8? 2. How many 4s are there in 12? 3. It looks like factors of 5, right? For 10 over 15. How many 5s are in 10? 2. How many 5s are in 15? 3. And it looks like all our sides uh, are having the same proportionality to one another. So basically, all you have to say is triangle um, JGH is similar to triangle. Sorry, that's a terrible triangle. I know. To triangle NLM. All right, and that's because all the corresponding sides are proportional. So remember, when they talk about similarity, they're talking about proportionality when it comes to sides. Angles still have to be congruent. All right, number C. Oh wow. Yeah, that's definitely on you. Number D, definitely on you. Number E, definitely on you. F, definitely on you. Okay, so those are for you to do. All right, number 18. So we got a building. It's 100 feet tall. I'm going to draw a pretty picture because I need that because I'm visual, just like 80 other percent of our people. Sorry, that's a terrible, man, that's a terrible drawing. There we go. All right, so there's our 100-foot building. All right, 100-foot building tall at the same time of the day. So Julia, who is 5 feet tall, casts a shadow of 4 feet. So here's Julia. Obviously, this drawing's not drawn to scale. She's 5 feet, but her shadow is 4 feet. All right, and we're really, I'm assuming Jilly or Julia is a right triangle, right? What would the length of the building's shadow be? All right. So first things first, their angle of incline would actually be the same because the sun is going across, just like with Eratosthenes and the Library of Alexandria to I think his birthplace, Cyrene. Uh, that guy figured out the size of the planet back in the day. So these two angles are congruent to each other. So what does the length of the shadow be? So let's find out. Well, um, let's talk about proportionality. We have okay in terms of the building. Okay, we're solving for the building's shadow, right? So the building should be proportional to Julia, right? That means the building's shadow should be in relationship to its height. So the building's height, as should be Julia's height or Julia's shadow. Sorry, to Julia's height. So this is really shadow to height kind of proportionality. Now, the building's shadow, we don't know. Okay, so we do not know that, and we represent it as x, but the building's height we know to be 100 feet. And that should be proportional to Julia's shadow, which was 4 feet, and Julia's height, which was 5 feet. So let's go ahead and isolate our variable, x. We have that dividing 100 there. How do you get rid of a dividing 100? We multiply, right? But remember what you do to one side, you have to do to the other. So I'm just going to do that to show you that I'm multiplying that 100 with both the left hand and right hand side. And you should get 400, right? 4 times 100 divided by that 5. And that should give you 80 feet. So yeah, our shadow for our building should be 80 feet in length. All right, so here we go. This is still proportionality. Basically, we're trying to solve for SR. I'll call that X. All right, but we do know he should be similar to VW, right? All right, so X should be similar to VW, which is 60, but that is in proportionality to, well, the bigger triangle has VS given to you as 110, but the smaller second smallest, so it's like this. It's like this is you're going to compare the smallest legs in relation to their second uh, largest or the medium side length for the triangles. So you have 110 on the bigger triangle, but the smaller triangle you got 11. So let's go ahead. Same thing as with Julia, and that building. Let's multiply by that 110, and you should get x equaling 660 divided by that 11. So you should get, let's see, let's make sure, 660 divided by 110, 6. All right, so that's not just for X, that's for SRRS, right? So be aware of that. All right, this one right here, that's for you to do. Definitely get your practice in. See what is to what. Be aware of what you're solving for. All right, this one is very identical to the whole Julia to the building, except now you're trying to find the height of the tree. And I'm going to go ahead and give you a hint on how to set that up. There it is. There's the hint. That's for you to do. All right. Height to height, and then shadow to shadow. Oh, more Jillian questions or Julia questions. Sorry, I have a kid named Jilly, so every time I say Julian, I want to say, or Julia, I want to say Jillian. All right, so that's another homework. Height of the building, right, to his shadow should equal the height of that person who's got a slunched neck, right, to their shadow. That's another hint on how to set that up. All right, number 20. What must be the length of CY for BC to be parallel to XY? Ooh, that's a nice one. So that's going along with the idea of proportionality based upon parallelism. Um, so let's go ahead and take a look at that. So CY should be proportional to BX. So CY is to BX, which is 4, right? Which is to AY, right? The longer piece, which is 10, to AX, all right, which is the other long piece, but it's over there. How do you get rid of a dividing 4? Multiply, just remember what you do to one side, do the other. That's why I'm using those parentheses. And you're going to get 40 divided by 9 for CY. And that's going to be approximately 4 point something. Yeah, okay, 4.4. 4.4 repeating, so yeah, just 4.4 would work. All right, number 21, definitely same situation, just different numbers. Definitely for you to try out, all right? All right, so are these guys parallel? All right, so basically we have this guy is to that guy, so NL or LN, which is 15, to KN, which is 21, should be to NJ is to MJ, which is 42. So 30 is to that 42. All right, let's see if I can reduce. I can reduce by 3 for the 15 and 21, right? So how many 3s are there in 15? 5. How many 3s are in 21? 7. So I'm factoring here, working on my factors. I think 3 also, wait, 5, 7, can I do, no, 6? Yeah, I can do 6. How many 6s are in 30? 5. How many 6s are in 42? 7. Look at that. They equal each other, therefore MN is going to be parallel to KL because, they're proportional. Uh, the sides, so all the sides are proportional. All right, so if they equal each other like that, you're good. Don't forget you need to reduce. So need to reduce. All right, so factor them down until you see it. All right, number 23 is similar to what I just did, just different numbers, and that's definitely for you to try out. All right, so if EF is parallel to BC, so if EF is parallel to BC, that's what those symbols mean. What relationship exists within the triangle? Well, if your distance, if EF was 50 feet in distance, then BC, if it's parallel, is going to be twice as much. All right, in the sense of distance. All right, so also the angles. This angle will be uh, congruent to that angle. This angle here will be congruent with this angle right here. All right, so be aware of the distance as well and what it does to the lengths. So EF is going to basically, or EF is going to be half of BC, and going the other way with it, BC is going to be 2 times bigger than EF. So be aware of that. All right, number 25. What is the surface area for a rectangular prism? That is 5 inches by 3 inches by 2 inches. Um, surface area. Okay, so surface area. Remember, surface area, you have a net, right? We have, um, and I know we did this with the fish tank project, but let me see if I could draw the net real quick just for you guys to see it. All right, so I'm trying to draw it as best as I can. Give me a break, but whenever we build like an aquarium or something like that, you take these sheets of acrylic or glass and you cut them, and it's 2D until you put them all together. I think I need one more. Oh, no, I'm good. I'm good. Okay. Um, but notice it's like, well, you have several objects to worry and consider about. Um, so we're going to do this. We're going to do, if these are guys are 2 feet and our height is 3 feet, and then our length is 5 feet. Um, in reality, we have 5 times 2. That gives us 10 here. It gives us 10 here. Um, this is 3 by 2, so that's 6. This is also going to be the same, right? And then 10, 10. What I'm really doing is I'm breaking down the use of this formula, which is basically you have 2 times whatever the length, width times the length. Sorry, that was a crazy W. Plus the height times the length plus the height times the width. All right, so if you plug those all in, you should get 3 times 5. Wait, length. Hold on, let me do this. Yeah, 3 times 5. Just making sure I'm plugging in the numbers here. Times 2 times 5. Sorry, that's a weird 5. Plus the h times w. H again is 2 times the w, which is 3. All right, so we got 3 times 5, that's 15. 2 times 5, that's 10. 2 times 3, that's 6. Hey, hey, how many sixes do we have? 2, right? How many tens do we have? Wait a minute. Hold on. Let me figure out this 15 real quick. So 15 plus 10, that's 25. 25 plus 6, that's 31. And 2 times 31 is 62. Am I missing a piece? I really starting to feel like I'm missing a piece. Why do I feel like I'm missing a piece? Hold on. Let me really think three-dimensionally here. Boom, boom. 1, 2, 3, 4. Yeah. Okay, I got 12 plus that, which is 40. Huh. Don't know where I was going with that idea. But if you use the formula, you get 62. Dang. Ooh, don't forget, we're talking about surface area. It's not just 62. Let's remember context, please. It's not just 62. It's 62. We're talking about inches. So we're talking about 62 square inches. Man, I really, because I have those 2 6s, right? That's 12. 12 plus 10, 22, 32 plus that other 10, right? 42, 52. Am I missing like another side? Because then that would be 62, right? Yeah, I feel like I'm missing something. Yeah, wow, three-dimensional fail. But yeah, 62 square inches. But that's the idea there. All right, a cone. All right, so and they give us the height. Lovely. They give us the base diameter of 6. So that means our radius is half that, right? Which is what's half of 6? 3. 3 inches. What is the volume of the cone? So remember the volume formula for a cone. It's going to be 1/3 pi r squared times the height. And I'll tell you what, you finish the rest. They already give you the height, right? They already give you the or the diameter, which is the radius, right? You guys know what to plug in, and just let me know what you guys get for your volume. All right, number 27. Basically, you have this two-dimensional piece here, but if you spin it around, it goes around, right? You guys ever spin a coin or flip a coin really fast, and you spin it really fast, and it almost looks like a perfect sphere? Like this piece just keeps spinning around and around, and I'm trying to draw as perfectly round as I can with the touchpad, which is a challenge within its own. But it basically turns into a sphere. If I could spell a sphere, geez, somebody's working during their weekend. All right, here we go. Sphere. If you try it with this guy, right, and he spins all the way around. Oh, that's a terrible drawing. But if you spin him all the way around, he's going to look like a cylinder. Okay. You guys do this one. What is this guy going to do if you rotate upon that given axis 360 degrees? So you're going to be spinning it. All right. So what is that guy going to look like? All right. Probability. So standard deck of cards. Find the following probabilities of randomly choosing a queen. Well, how many queens are there? Well, first things first, our sample space needs to be addressed. There are 52 cards, right, in the deck. So that means sample space. We have to be aware of that. Now, how many queens are there, right? So we're looking for the probability. The probability of picking a queen is going to be, well, how many queens are there? Oh, whoa. How many queens are there in a deck? And if you don't know that answer right off the top of your head, I want to tell you you're doing it wrong. All right. Somebody needs to go camping, have those wonderful nights with your parents where you're just playing cards and you're just ticking them off because you're starting to figure out how to play cards. All right. So you have the number of queens that you have in your deck out of your entire sample space. And there are 4 queens, right? There's a queen of spades, diamonds, clubs, uh, and hearts, right? Out of the 52, I can actually reduce, but if you just type this in your calculator, 4 divided by 52, you get about 0.0764, and that's basically 7.7% chance. So that's probability for you there. All right, randomly choosing a queen, given that it's a red card. So we got some conditional probabilities here. Tell you what, that one's for you. How many queens are really red? And that's going to determine, well, how many queens are there going to be for you. All right. And it's very much like the first part A, just instead of 4, you're looking at a different number. All right. Randomly choosing an ace, given that it's a heart. So again, we got a condition. Well, how many hearts are there? That's an ace. Just one, right? And then, well, how many hearts are there? There's 13. So 1 out of 13, it's kind of coincidental. It's also going to be 7.7%. Yeah, that's interesting. All right, part D, randomly choosing a face card, given that it's a black card. Well, first things first, how many face cards are there? Um, so remember face cards, we got jacks, we got queens, we got kings, not aces. But there's 4 suits, right? So there's going to be 4 groups of jacks, queens, and kings. Uh, so be aware of that. But we also are making sure that it's a black card. And if you remember, half the deck, half of those 52 cards are black. So what's half of 52? 26, right? So those are your black cards. All right. But of those black cards, yeah, we have 12 face cards, right? But only half of them, so 6 of them, are going to be black, right? So black, given that it's given that it's black, right? Face cards. All right. So 6 out of 26 in your calculator, you should get 0.0764. 231. And we can go ahead and say and chalk it up to 23.1%. All right. Let's see. A bag contains different types of rocks: 2 granite, 5 sandstone, 3 shell, 6 quartz. Find the following probability of randomly choosing granite. Well, how many rocks are there? There's 2, right? So sample space, we have 2 plus 5, that's 7, plus a 3, that's 10, plus the 6, and that's 16. So our sample space is 16 rocks. How many of them are granite? So the event or the number of granite, we'll call this event A, is 2. Well, probability is going to be the number in granite divided by the whole sample space. So that's just really going to be 2 out of 16. And we can reduce, that's just 1 out of 8. So there's a 1 out of 8 chance. If you use a calculator, 0.125, move the decimal over if we're talking about percent, 2 places, 1, 2, and you get 12.5%. So be aware of that. That's a 2, sorry. Randomly choosing sandstone, same kind of concept. That's definitely for you. Randomly choosing a rock that is not quartz, I want that to be you. Yeah. Think about the complement. All right, not quartz. So think about this, and this is my hint. 100% chance you're pulling something out, minus the probability that it's a quartz, and you're going to find out what that chance is. All right, number 30, calculate the following probabilities: flipping a coins and getting tails. Well, there's one tail out of 2 possible outcomes. All right, so that's 50%. All right, flipping a coin twice and getting tails first. So you have a 1 out of 2 chance, and then you also have another 1 out of 2 chance as you keep going. 1 times 1 is 1, 2 times 2 is 4. There's a 1 out of 4 chance that you're going to get that situation. All right, so flipping a coin 3 times and getting 2 tails and a head. Tell you what, that's for you. Get your practice in and let me know how it goes. Okay, guys, I think that is it for your study guide. Best of luck. If you guys have questions, let me know. And yeah, good luck. And make sure you guys study. Take your time. Hey, do you guys see this? Like, my computer is literally trying to process this. My CPU is running at 59 degrees Celsius, just trying to render all this. So cool. Science. All right. Good luck, guys. And let me know if you have any questions. Feel free to come see me. Talk to your teacher if you have any questions about the video, or anything specific about where I went to what and how I got certain things. All right. Good luck.